All right, this is question number 7 from lesson 1B. This one it's mainly just working with pictorially drawing your vectors. So we have radar in the control tower of an airport shows aircraft at the following directions, and they give us 3. They want in a diagram to draw the vectors showing the position of the 3 aircrafts in relation to the tower. So I'm going to draw a relatively large grid here, and I'm just going to shrink that down so I have a little bit more space. So I'm going to draw myself a grid. Well, not really a grid. I'm going to draw a larger XY axis here, and I'm going to have that as my north, east, south, and west. So I'm going to put the radar control tower at the origin. All right. So everything's going to be referenced from my origin. So the first airplane, it is north 50 degrees. So you start by facing north and you rotate to the east 50 degrees. So it'll look something like that, 50 degrees. And the magnitude of that vector is 5 kilometers. So there is our first plane. The second one, I'll change colors, is located north 70 west. So again, you go up the north and you rotate toward the west. 70 will be over here. So I'll put 70 degrees there, and it is 8 kilometers. And finally, I'll go to a red, the last one, and it is located south. So this time from the radar or the control tower, I'm going to head south. I'm going to rotate toward the west 20 degrees. So it's going to look like that. There's my 20 degrees, and its magnitude is 12 kilometers. So there's A part taken care of for us. B part, the aircraft is traveling at velocities of 400, 550, and 175. So each of those airplanes are going at a specific velocity. So they want us to draw a velocity vector to represent their direction. So what I'm going to do, I'm going to do it all in the same one because I made it large enough, not necessary for yourself. So on each of these vector heads, I'm going to draw a new little tiny XY axes. Try to make them so they actually look right. There, there, and there, and there. And I'm going to draw the velocities at these points so that you can see, that's the displacement, how far they are. And then the second vector I'm going to draw is showing where they're heading. So plane number 1, that's the one up in the top quadrant right here. Still, it's traveling north at 450. So its velocity vector is going to look like that. 450 kph. So there's so it's heading away from the tower, so it could have taken off, and it's heading to its destination. The second one is traveling at 550. It's heading north 70 west, so north. It's going to rotate that way. So north 70 west is actually on the same line as its position. So its velocity is 550 kph. So that one there, it is along the same line. So it took off in that direction by the look of it, and it's heading that direction. So its velocity vector and displacement vector are pointing the same direction. My last one, it's heading north 20 degrees east, so that's my red one. So north 20 degrees to the east. So it's going to be in this direction. So it's actually heading, it's also in the same line as its approach vector, or its displacement vector. So this one looks like it's heading straight into the control tower for landing. All right, so its velocity vector is in the opposite direction of its displacement. There you go. There's what question 7, or what they wanted, and that's why there's really no answer in the solutions. If you have any questions, let me know.